There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. We already covered both supervised and unsupervised learning in the past videos, and today we'll focus about reinforcement learning. Reinforcement learning is a type of machine learning where an agent learns through trial and error, just like humans do. Think of it this way. When you're learning to ride a bike, you might fall a few times, but over time, you learn what works and what doesn't. Each mistake is a lesson, and each success is a reward. That's trial and error. In reinforcement learning, a computer, also called the agent, interacts with an environment, takes actions, and gets rewards or penalties based on how good or how bad these actions are. The goal is to learn which actions lead to the best long-term results. Here is a real-life example for reinforcement learning, which is self-driving cars. In this example, the car, which is the agent, sees its environment. This environment consists of roads, signs, and traffic. It decides to accelerate, brake, or steer. And safe driving means rewards, and bad moves means penalties. Over time, the car learns to drive better by maximizing rewards and minimizing penalties. Here are more examples. Game AI. As bots learn to play and win games, like for example in chess, by playing thousands of times and improving over time. Another example is recommendation systems, like in platforms, for example Netflix or YouTube. They use reinforcement learning to suggest better movies or videos based on what you click. Also robotics, as robots learn to walk, pick up objects, or even fold clothes by practicing and improving over time. Or in finance, as algorithms use reinforcement learning to test and optimize trading strategies for higher returns. The advantages of reinforcement learning are the following. First, unlike supervised learning, it doesn't need labeled data as it learns from experience, which can save time and effort. It can also adapt to changing environments. It focuses on long-term rewards, and it works well in complex and dynamic tasks. The downsides are the following. First, it requires a lot of data and computation. It can also be risky in the real world. For example, imagine a flawed decision in an autopilot system for a plane. This would lead the plane to crash.